So I don't know who's gonna come in here, but it's gonna be a document reading. It's not gonna be more than 1 hour. I'm probably not gonna be taking any questions, to be perfectly honest with you. But I'm gonna read these docs to you guys. You guys didn't appreciate the fucking video that I posted up. YouTube did some crazy shit to me with regard to the music I was trying to attach. The last relevant sage said it was the lazy ass video I ever did. So I'll give you that one there, Mr. Sage. But I'm gonna do a document read for you guys on the real flat earth math and model. Okay? We'll break it down for you. Break it down, break it down, break it down. See what we can see here. Pull up some of these docs for you. Somebody sent me this today, and I figured, hey, why not share it, you know? Right? That's what I always do. I heard people talking about mathematics on another channel. I hate people talking about the fucking mathematics on every goddamn channel. But I don't ever see any fucking documentation. That's what's fucking pissing me off. Max Egan was right. Motherfuckers just keep going round and round and round in a circular fucking argument, talking about the same shit, and they ain't showing no fucking documentation whatsoever. Nobody's showing any fucking documentation. And I'm getting goddamn fucking sick and tired of it. Here it is. I get people who help me find the fucking thing and do some fucking research. Says, hey, Robert, you understand this. Here you go. Break it down for people. Show it to them. You guys want to keep going back to these channels. I don't think you're going to the channels to get educated. I think you're going to the channels because you love the fucking drama. I ain't going to give you no drama. I'm going to just kick it to you. So let's see how many people are actually out there who may be inside of this. So I'm going to I got 10 people watching. I got a couple of people in chat. Fuck, I ain't waiting for nobody special. So what I'm going to do is I'm going to do a share screen, and I'm going to read through some of these documents, 2 documents. Okay, I'm going to read through 2 documents which actually discuss specifically using the flat earth model and flat earth mathematics. Okay, we're going to put this shit to rest. This will be the video of all videos. You ever want to know what the mathematics are for the flat earth, you are going to refer everyone to this fucking video. Period. Okay? So here we go. And don't start fucking complaining and chat about my fucking crickets. They ain't fucking a goddamn thing I can do about it. They're just big ass fucking crickets. So here we go, peeps. Here we go. Present this shit to everybody. Let me make sure the shit is actually showing up on the watch page. I don't see nothing yet. Here, refresh. Okay. We should be good to go. So this presentation is exactly what is titled, Real Flat Earth Math and Model. I'm showing 2 documents. I'm going to go through some reading for you guys. And after that, we'll see if we can go through any questions. I ain't looking to have fucking nobody on the fucking panel. So I don't need to have anybody on the fucking panel. So here we go. Let's start with Freeman Dyson first. All right. So here we go, people. This Freeman Dyson. All right. He talks about the flat earth model. And I'll read it verbatim. All right. As a rough approximation to describe the configuration of the earth in the neighborhood of a given point on the surface, consider an infinite half space, x to the third is less than 0, filled with a uniform isotropic elastic medium. Don't get yourself all caught up with this fucking language, okay? Just don't get yourself caught up with this. Insofar as the response of the Earth to a gravitational wave is mainly a localized surface effect, the flat Earth model will be qualitatively correct. The uniformity and isotropy of the medium mean that the elastic velocities s and v are constants, so that the coupling term in equation 2.30 vanishes. Okay, we'll show that. There is no effect at all of a gravitational wave in the interior of the medium. Okay? The solutions of equations are plane waves running away from the surface with velocities s and v. Incoming elastic waves are excluded since we are neglecting signals propagating through the Earth from the other side. All right? They're breaking down the equations. This is geometry and calculus, people. This shit ain't complicated. But we're not going to get ourselves caught up in this, all right? I'm going to actually use this data to put together a nice visual model for you guys where I can input all of this and give you a video illustration. That'll be down the road, man, because I'm in transition right now. We're in the process of moving, going somewhere else. Actually moving to another country, man. You know, where I can have a lot more access to a lot more people, a lot more things. Okay, so let's go through this here. Let's go through this. Scanning. See what we got here. And I'm going to show you how this document actually compares to the next document that I'm going to present regarding tsunamis on flat Earth model. Okay, this talks about gravitational waves. We're not going to play semantics with discussing the whole gravitational wave thing. And then I'm going to pull up a nice little bio on who Freeman Dyson really is. Okay, very important guy. Anybody that wants to debate this guy, shit, you better go get yourself a 6-figure job and teach mathematics at a top university. Because if you think you know something more than what Freeman Dyson knows, you shouldn't be on fucking YouTube. This is shit I'm learning right now in physics. Right now. Okay, so let's see what they say here. Equation 3.12. All right. Gives complete information concerning the phase, amplitude, and direction of the seismic displacement induced at the Earth's surface by a gravitational wave. In this approximation, all points on the surface move together in phase. All right? Can't do that shit on the ball. Thus, all the instruments in a seismic array should respond coherently to a gravitational wave, provided that the extent of the array is small compared with the free space wavelength, 2 times pi times the speed of light divided by the width, a condition which is well satisfied in practice for waves in the 1 Hertz band. Okay, let's see here. A lot of this shit's important because it talks about the flux energy carried into the Earth by the elastic wave. Talking about how the land masses and the rest of the Earth is kind of, you know, jiggling a little bit like a fucking giant fucking piece of jello. But it's just insignificant. You know, we don't feel that type of movement all the time. But there is a lot of seismic activity all around the planet. You can go to online and search any earthquake detector web application, and it'll show you all the seismic activity all around the planet at any given time. That seismic activity is actually generating waves around the planet. So if you got all these waves literally propagating over a spherical surface, that spherical surface is going to vibrate violently. That doesn't happen like that. All this stuff happens on a flat plane surface. Okay, relatively flat. This has to be compared with the energy flux and the incident gravitational wave. Most of this is just all math. Let's see here. Let's go on. Okay, some important numbers to remember. 8 pi times gravity times plane. Let's see here. I went over this document a little bit, but I'm going to read this section too. It is noteworthy that the dissipation of seismic energy in the Earth plays no role in our analysis. There are, of course, dissipative processes which should be included in the equation of motion in an exact theory. But in the flat Earth model, it makes no difference to the elastic displacements at the surface whether the ingoing elastic waves propagate freely to infinity or are dissipated in the interior. The details of the dissipative processes would be important only if the surface effects could be amplified by reflective waves from the interior. If reflective waves in the Earth are important, standing wave patterns can exist, and the amplitude of seismic response will depend on the details of the local topography and local dampening effects. Okay, so showing no bias, we're going to talk about effects of sphericity and rotation. The normal modes of vibration of a uniform isotropic solid sphere have been fully described by Love in 1927. However, it is pointless to use these modes in the present context, since the Earth as a whole is not even approximately uniform. Now, this is important because this is what I've been saying in some of my videos. It is pointless to use these modes, a uniform isotropic solid sphere. That's what they said. It's pointless to use a uniform isotropic solid sphere in the present context, since the Earth as a whole, people, is not even approximately uniform. Now, what do they mean by that? They mean that you have the solid mass, relatively flat surface and the waters, right, that are fixed. The rest of the Earth as a whole, the atmospheres, the multi-layers, pressure, they contract and expand. We don't know how large each one is, how vast it may be, how far it may go, all right? But generally speaking, they're saying here that the normal modes of vibration of a uniform isotropic solid sphere is pointless to even consider it, because the rest of the Earth is not uniform. They don't know. So they're not even going to factor in the effects of sphericity and rotation. It is reasonable to consider the Earth as an approximately uniform within a distance of a few tens of kilometers from a given point on the surface. Now, very important. It is reasonable to consider the Earth as approximately uniform within a distance of a few tens of kilometers from a given point on the surface. They mean surface, they mean the solid masses. But within this distance, it is also a good approximation to consider the Earth flat. A uniform sphere model would have no advantage over the much simpler flat Earth model. I'll say that again. Freeman Dyson says this, not Robert. Uniform sphere model would have no advantage over the much simpler flat Earth model. People want to believe that. They want to believe so badly. They need to stick to that. They want to stick to the fact that it's a ball. It's a sphere. But Freeman Dyson, who's smarter than every fucking person you guys are arguing with, says there's no advantage over the more simpler model. The simplicity is that you're standing on a flat plane surface, flat Earth model. In this section, we shall calculate the seismic response to a gravitational wave on a spherical rotating Earth, assuming that the local dynamics is described by the flat Earth equations. So to even consider a spherical rotating Earth, you're assuming the local dynamics is described by the flat Earth equations. There's no fucking math for a sphere. There's no fucking math for a rotating spherical Earth. You have to use flat Earth equations. And I don't know what else needs to be said. I don't know how many times that has to be said. I said it. I think I've probably said it. This is the third time I've said it. There's no math. There's no fucking math. This is called the flat Earth model, not the fucking sphere model. There's no math for a sphere. We consider only the kinetical effects of sphericity and rotation. We consider only the kinetical effects of sphericity and rotation produced by the motion of the source relative to an earth-bound detector. The effects of rotation would be qualitatively similar if we replaced the flat Earth model by a more exact dynamical theory. The main features of the rotation effects arise from purely group theoretical considerations. Let me say that again. The main features of the rotation effects arise from purely group theoretical considerations. Sphericity and rotation is a fucking theoretical construct. It's not reality. The flat Earth model is reality. You got to use flat Earth equations to even theorize what the fuck could happen on a ball. Okay? Let's get that shit straight right now. I don't even need to go there anymore. Let's see what else we have here. Okay, they say, what is this? Energy times 1 times 2 times 3 be a coordinate system with origin at the center of the Earth, the 3 direction pointing to the North Pole, and the 1, 2 directions fixed in space. Okay? Let x times 1 times 2 times 3 be a coordinate system with the origin at a point O on the Earth's surface and rotating with the Earth, x times 3 being vertically downward, x times 1 horizontally north, x times 2 horizontally east. Let r omega be the Earth's radius and angular velocity, and let a be the latitude of O. The relation between the two coordinate systems is, okay, and they describe it. Again, more mathematics. Okay, let's see if we can go here. Let's see what we got here. More math, okay. More flat Earth talk. We are here assuming that the flat Earth model gives a valid description of the dynamics of Earth's motions in the region adjacent to the point 0. Okay? Now, they describe point 0. Where do we get that? Is the Doppler effect produced by the motion of the detector at O relative to the distant source. So O is actually a fixed point, stationary. That's a stationary point. So when they say we are assuming that the flat Earth model gives a valid description of the dynamics of Earth's motion in a region adjacent to the point O. So this is describing the Earth being fixed at a fixed point. And you're looking out up vertically or at an angle in any which direction from a fixed point, meaning the Earth's not rotating. The rest of the atmospheres are. The upper atmospheres are rotating. You're using some sort of constellational reference system as a detector to determine what the entire Earth's rotation would be. That's what I get from it. If anybody else gets anything else from it, let me know. I might be wrong. I sure as hell ain't right all the time. Oh, wait, what does it say here? Angular momentum about the Earth's rotation axis from equation 4.5. Okay. Let's see, more mathematics. Again, I'm going to save all this because I'm going to be putting it into a computer model to give a visual reference frame of what this really means, what it really looks like. Let's see here. If we integrate this energy flux over the entire surface of the Earth, we find the total energy absorbed per second in the frequency width equals pi. That want to be okay. Hang on a second. Some common language I've seen NASA use before. The same cross section is obtained for a non-rotating Earth by integrating equation 3.16. I'm not going to go all the way back to 3.16. Should I or shouldn't I? Yeah, that's going fucking all the way back. 3.16 was this. Hence the proportion of the energy crossing the surface which is converted into elastic energy. And that's the equation for 3.16. Okay. Let's see what we got here. I haven't read this whole document before. I just got it tonight. So I figured I'd share it with you guys. Going over this. See what we got here. What do we got? What do we got? This is funny. I actually read this. He says here, finally, we should remember the history of radio astronomy, which was greatly hampered in its early stages by theoretical estimates predicting that few detectable sources should exist. The predictions were wrong because the majority of sources were objects unknown to optical astronomers at the time. Whenever a new channel of observation of the universe is opened, we should expect to see something unexpected. For this reason, above all, the seismic detection of pulsars is not as hopeless as enterprise as the calculations here reported would make it appear. And he just gives thanks and his reference sources. Okay, great. That's that paper. That's this source. Anyone wants to see this, you can, I'll put it in a description link for you, and you can actually read this entire damn thing. And it's titled Selected Papers of Freeman Dyson with Commentary. Foreword by Elliot Leib, American Mathematical Society. So this is real flat earth math. Okay? Real flat earth math. I'll put the link in the description for you guys so that you can check it out yourself. This entire conversation actually deals with field theory physics, quantum electrodynamics, gravitation, and number theory. Don't you just love that? All right, let's go to the next document. Booyah! This document is titled, from Geophysics Journal, Department of Earth and Planetary Sciences, MIT, Robert Comer, The Tsunami Mode of a Flat Earth and Its Excitation by Earthquake Sources, 1984. It was received in 1983, April 25th. Let's see what the summary says. Tsunami generation by earthquakes in a flat, isotropic, elastic, vertically stratified Earth, underlying a uniform depth, incompressible ocean, can be studied in terms of the tsunami normal mode of the combined ocean, solid Earth system. we derived in a way that demonstrates their natural extension from traditional approaches to tsunami theory. The equations and boundary conditions governing the tsunami mode displacement and stress eigenfunctions then solve the excitation problem by a variational method. This leads to the straightforward expression for the far-field tsunami displacements due to the point momentum tensor source in the solid Earth. Numerically computed spectra waveforms reveal clearly the dependence of the far-field tsunami on the source depth, duration, moment, and mechanism. Okie dokie. Let's see what we can see here. Let's get through all of the verbose fucking scientific bullshit nonsense. And let's see what they have to say regarding if they're just using flat Earth as a reference or if they're using it as a literal model. Okay? Let's see that. Let's see what we can see here. Okay. Here we go. Cherry picked like a motherfucker. Here we go. What does it say? And although the works just cited are all based on flat Earth models, none makes reference to the tsunami normal mode of a flat ocean Earth system. Ward has introduced normal modes in the tsunami generation problem, but in the context of a spherically symmetric ocean Earth model. He formulated the equations of motion in a manner originally applied to the Earth's free oscillations and made use of a very general result to obtain the tsunami mode excitation. Now I want you guys to understand this, being a graduate student, he is not, all he's doing, he's developed a critical analysis of what one other researcher discussed. This is not what this particular author agrees with. Okay? He doesn't agree with this. You do this in research study. You find other research, peer-reviewed and scholarly review, and you find out what's missing. What are they discussing and what didn't they discuss? What should they be discussing? Okay? So, let's see what he said about Ward. Ward's results are useful and important, yet it is nonetheless also rewarding to explore tsunami normal mode excitation using a flat Earth model. At the very least, two independent solutions of very similar problems can be used to check one another. Also, no significant increase in accuracy can be obtained simply by going from a flat Earth model to a spherical one. I say again, no significant increase in accuracy can be obtained simply by going from a flat Earth model to a spherical one. Since the tsunami mode engine functions, unlike those of long-period seismic surface waves, do not penetrate the solid Earth very deeply, and a correction for geometric spreading on a spherical rather than flat surface is easily applied. Of course, the geometric spreading of a real tsunami is different from either idealized case due to the bathymetric variations resulting in variations in wave speed in the real oceans. Okay, let's see here. I'm talking about gravity, surface gravity, waves, elastic terms in the ocean. Scanning very fast here. Scanning very fast, people. Some of you should be reading this as I go along as well. Okay, let's see here. A side benefit is that we are able to build a conceptual bridge between the traditional approach to tsunami modeling based on the hydrodynamics of an incompressible flat ocean and the normal mode methods. We first develop the equations governing the tsunami mode, then study its excitation. We note here that the flat Earth excitation problem differs substantially from the corresponding spherical Earth problem. There is a continuum of frequencies and wave numbers for a flat Earth, but frequencies and angular orders are discrete on a spherical Earth. Also, the normal modes of a finite body form a complete basis for the small amplitude oscillations of the body, but those of an infinite body, like the flat Earth, those of an infinite body like the flat Earth, do not. Wow, they consider surface plane to be infinite. That's interesting. Consequently, the theoretical development of the solution to the excitation problem given here is totally distinct from Ward's. Finally, we remark that in common with Ward, we assume the ocean to be inviscid and deal only with linearized equations of motion and boundary conditions. Linear, okay? The form assumption was justified by Stoneley, and linearity, which is usually assumed in seismology but often not in hydrodynamics, is considered in the following brief section. Okay. Let's see here. Go over this pretty quick. What do we got here? What do we got? Okay, let's get to the meat of this, guys. Let's get to the meat of it. The tsunami mode. Okay. We consider plain water waves propagating across a flat, ideal, incompressible ocean of uniform depth h, overlying a solid isotropic Earth whose elastic parameters and density vary only with depth. Figure 1 illustrates the geometry and coordinate system chosen for the problem. A constant gravitational field with accelerating g acts in a downward, positive z direction in the fluid and is ignored in the solid. The x and z components of the Lagrangian displacement field may be assumed to have the form. Okay. I know this shit sounds complex, people, because it is complex to me as well. Our approach is so far is identical to the displacement stress over vector formulation for the Rayleigh wave modes of a flat, vertically stratified Earth. This is not surprising, since both wave types involve particle motion in a vertical plane parallel to the propagation direction. Therefore, for convenience, we adopt the notation which Aki and Richards applied to Rayleigh waves, and whenever it is helpful, we refer directly to their equation numbers, prefacing each with AR. Okay. I can see how this would be fucking difficult. You're trying to argue with a globe and tell them, hey, the Earth is flat. Then you got to explain this shit, and they're like, what the fuck? What are you saying? And that's the point you take back to them. What the fuck are you saying? Can you pull out some shit like this to prove that the Earth is round? No, they can't, because there's no math for a sphere. None. The simplest model is a flat Earth model. I don't understand why 7 billion people don't want to go with simplicity. They want to go with what's difficult, that NASA can't even explain. NASA can't even explain why the Earth is the way it is. Can't even. Oh, you're talking about static equilibrium. Okay. Usually when I go through these papers, I usually read the summary and abstract and go straight to the fucking conclusion. Instead of going through all of this, and then I start reading the meat of it and see how they came up with the solution. Okay, what is this? Ocean floor, elastic half space underlying ocean, and it shows the declination in the ocean. Phase velocity. Oh, they're trying to say that there's some movement going on under the ocean, which is actually creating the perception of movement? Huh. I think that's what it's saying. Tsunami phase velocities for 4-kilometer deep ocean. The parameters chosen for the half space are period scale is valid for both curves, but the wavelength scale is determined for the rigid bottom case. Okay. Oh, this can be boring sometimes, people. Very boring. I wouldn't be surprised if there's fucking one person listening right now. Wouldn't be surprised. It's not always going to be mind-blowing, fantastic shit, people. But I'm really getting tired of people talking about this shit. I'm not looking for the documentation. So I figure that somebody's going to want to really look into this to understand what it is that's being said. Let's see. A lot of the shit they write on is just repetitive, redundant, verbose language meant to fucking just confuse you. You gotta go reference back the shit they talked about 2 or 3 pages before. Only find out that they could have wrote this much more simply by saying, okay, this is what we came up with, and this is how we did it. Point force response to tsunami residue. I'm not going to say this is all flat earth math, but some of it is. Scanning through this very quickly, I don't see anything talking about a sphere in here. Or any numbers including circumference, Earth's rotation, speed. It's not talking about that at all. It's talking about energy displacement, fluid dynamics. It's literally what they're discussing. That is literally what they're discussing. Okay, get back to some textual data here. Nothing to see there. Nothing to see there. What's we got here? Come on, man. Come on, give us something, man. I don't know, people. He discussed in the beginning of his paper, he didn't write about it anymore in the rest of the paper. He's relying on the mathematics to do the speaking. Could you imagine? You know, I got a thought, people, for a second. Looking at the complexity of this paper, talking about, you know, tsunami modeling based on flat Earth models, would it be possible that they create these papers with all this complex stochastic calculus and linear algebra to literally, people who believe in a globe, if you told them, okay, this proves the globe, I mean, would an average person be able to understand this shit? I don't think so. I think they literally hide the flat Earth, the reality of it, in these complex documents. And it's meant to frustrate you. It's meant to confuse you. Because you look at this for the first time, your first time coming into flat Earth, you take a look at this. If I presented this document to you and says, okay, you want to learn about the flat Earth? Here you go, read this. And then let's have a conversation. The first time you'd look at this, you'd be like, what the fuck? Are you fucking serious? This is what the flat earth is? This is the model? How the fuck am I going to understand? Fuck it. The earth's a fucking globe. I don't want to look at this shit. Let me look at NASA's photos. They make it intentionally complex. They're hiding the flat earth in this bullshit math. And I don't mean bullshit math as in it's right or wrong, but they convolute the document with all these calculations. Okay? All of these calculations. I guarantee you, if you spoke to the author about this and asked him to give you a 5-minute presentation to explain this fucking paper, he wouldn't be able to do it. He would not fucking be able to do it. What the hell is this? This guy, Robert Coleman, would not be able to explain this fucking paper. No fucking way. You just get frustrated. You want to say to him, hey, I read your paper, on tsunamis and using the flat earth model. So do you believe the earth is flat? And first thing he'd do is look at you and be like, oh, you're not one of those people, are you? The fuck do you mean I'm not one of those people? Motherfucker, you wrote a paper titled fucking tsunami using the fucking flat earth model. So what the fuck you write a paper about this shit for? If you don't believe it. See, it's these type of people we need to get in contact with. People like this who write these papers, and you just sit them down and say, hey, can you break it down for me? I want to understand this because I'm looking into the flat earth. I want to know how things work on the flat earth. Explain to me why you believe the earth is flat. And I guarantee you they'll get the fuck up and walk away. And if they could explain this to you, shit, more power to you. But I highly doubt it. I spoke to one person from the U.S. Army Research Laboratory who wrote a paper titled Electromagnetic Waves over a Flat Earth. No, electromagnetic wave propagation over a flat earth. The date of it is February 2011. I talked to one person. I talked to the guy who actually drafted that paper. I asked him, do you believe the earth is flat? Dude paused for a second, and he says, well, what does my paper say? I said, your paper says that you know that electromagnetic waves propagate over a flat earth model. So you believe the earth you walk on is flat. He says, well, if that's what the paper says, yeah, that's what I believe. But he wouldn't fucking say it. That's the problem I had. He wouldn't actually say it. He probably knew I was fucking recording his ass too. That's why I never posted that damn video. But I got his paper though. Electromagnetic wave propagation over a flat earth. February 2011, U.S. Army Research Laboratory. Just type that shit in Google right now. I guarantee you'll find it. Read it. It's some interesting shit. But yeah, look at this. We'll talk about the tsunami mode and its excitation. But you're going to draw a fucking goddamn ball. I mean, this doesn't make any fucking sense. 3 simple double couple focal mechanisms. A is a strike slip. B is a 45-degree thrust. And C is a vertical dip slip. The lower hemisphere is shown and compressional quadrants are shaded. The arrows show directions in which the tsunami waveforms from a point source correspond to elementary waveforms multiplied by the scalar movement. Whatever. This is incredible. That model made no sense at all. Not for me again. Okay. Dude mentioned flat earth in the beginning of his fucking paper and didn't mention anything else after that. See he used for it. Let's check out the references. You might be able to find some other papers online, guys. Let's see here. Oh boy. This shit just all talks about tsunamis. That's research for you. So let's do this. Let me let's type up Freeman. Let's see who Freeman Dyson is. Okay, and then I'm gonna end this. Yeah, let's see if there's any questions in there too. You guys know I fucking hate using fucking Wikipedia. I'm gonna find something a little bit better on him. Okay, let's go to this university. Let's read about Freeman Dyson. And then let's see, Freeman Dyson. I actually quoted him in a paper I wrote talking about technology as a gift of God. Freeman Dyson is now retired, having been for most of his life a professor of physics at the Institute for Advanced Study in Princeton. He was born in England and worked as a civilian scientist for the Royal Air Force in World War II. He graduated from Cambridge University in 1945 with a BA degree in mathematics. He went on to Cornell as a graduate student in 1947 and worked with Hans Bethe and Richard Feynman. Like, are they fucking important? His most useful contribution to science was the unification of the three versions of quantum electrodynamics invented by Feynman, Schwinger, and Tomanada. Okay, Tomanada. Cornell University made him a professor without bothering about his lack of PhD. He subsequently worked on nuclear reactors, solid-state physics, ferromagnetism, astrophysics, and biology, looking for problems where elegant mathematics could be usefully applied. He has written a number of books about science for the general public. Disturbing the Universe is a portrait gallery of people he has known during his career as a scientist. Weapons and Hope is the study of ethical problems of war and peace. Infinite in All Directions is a philosophical meditation based on Dyson's gift lectures on natural theology given at the University of Aberdeen in Scotland. Origins of Life is a study of one of his major unsolved problems of science. From Eros to Gaia is a collection of essays and lectures starting with a science fiction story written at the age of 9 and ending with a mugging in Washington at age 54. Imagine Worlds is an edited version of a set of lectures given in 1995 at the Hebrew University in Jerusalem about human destiny, literature, and science. The Sun, the Genome, and the Internet discusses the question of whether modern technology can be used to narrow the gap between rich and poor rather than widen it. The Scientist as a Rebel is a collection of book reviews and essays mostly published in the New York Review of Books. A many-colored glass, Reflections of the Place of Life in the Universe, is an edited version of a lectures given in 2004 at the University of Virginia. Dyson is a fellow of the American Physics Society, a member of the U.S. National Academy of Sciences, and a fellow of the Royal Society of London. In 2000, he was awarded the Templin Prize for Progress in Religion. In 2012, he was awarded the Henry Onkeak Prize at the August meeting of the International Mathematics Physics Congress. Okie dokie. I'm going to try to call this dude. Oh, hell yeah. I'm going to call this dude. He's going to be my next fucking phone call. His fucking phone number and cell phone. Oh, yeah. My next phone call conversation. I'm even trying to get this motherfucker on video. Freeman Dyson. Yep. Next Monday, this is going to be a live hangout, and we are going to talk to Mr. Freeman Dyson. You bet your ass. Oh, hell yeah. I'm talking to Freeman Dyson. Oh, yeah. He's the best thing I'm going to get to Neil deGrasse Tyson. You best believe that shit. So, has anybody got any questions? Who's out there? Who wants to call me names and all kinds of crazy ass racist shit? You saw the document, people. I gotta study that shit too. I'm still studying physics, man. I ain't no expert on this shit. I don't claim to be either. I understand it, but I think they put that math out there like that to really discourage people, the rest of the majority of people out there, 6 billion people, to say, I'm not interested in studying the flat earth. It's too fucking complicated. It's not complicated. Scientists say the simplest model is the flat earth model. That's what they're saying. The simplest model is the flat earth model. So if the earth is round, right, why you got to use a flat earth fucking mathematical equations for wave propagation and signal propagation? Think about that shit. That's like fucking around with a basketball and bouncing it on the hard court. Oh shit. That's right. They call that basketball, don't they? Shit. They sure as hell ain't throwing a fucking frisbee in that goddamn hoop, are they? Wonder why? Because it's too fucking complicated, isn't it? When you throw a frisbee, think about this. Has anybody ever played frisbee basketball? Where you literally are throwing a frisbee to see if you can hit the fucking hoop and get in there? Now think about this. You're throwing a disc in the air. It's got to be at the right trajectory. It's got to be spinning at the right speed to hit another round, flat disc object. That's fucking complex as hell to do. Complex as hell to do. Complex as hell. Yeah, it's called frisbee golf. Yeah, that's right. That's really a hard game to play, man. I hated it. I hated it. So anybody got anything else to say? Anything anybody want to share? I'm gonna put that link in there for you guys on the Dyson papers right now. Oh shit, I gotta put it in the description. So I'll do it and I'll post this. But again, there's a dude out there with a channel called Flat Earth Math. You can listen to him, or you can go back to this video, or you go to that link I'm gonna put in the description. It's up to you. He's a math teacher though. I don't discredit him for being a math teacher. He's teaching. Yeah, I'm in Colombia, man. It's with an O, popcorn. It ain't with a U. Colombia. That Dyson guy is also the dude that came up with the Dyson sphere. He did? The Dyson sphere? I never heard of that one. But I'm going to interview that dude next Monday. Be available, people. I think I'm gonna try to do the call around 1 or 2 o'clock in the afternoon. I gotta wait for my son to take a nap. So I'll do it when my son takes a nap. But I'm gonna call him. His damn phone number and cell phone number was on that damn website. You best believe I'm bookmarking that motherfucker. And I'm calling him. We're gonna speak to Freeman Dyson. That motherfucker's famous. And I'm gonna get him to admit the earth is flat. If I get him to admit the earth is flat, I ain't doing another fucking video until September. I guarantee you. I guarantee you. If I can get him to admit the earth is really flat, okay, and he don't know why the rest of everybody else don't believe it, that will be my last video until September. I hope that motherfucker gets 1 million hits too. That video should get 1 million hits. That'll tell you how many flat earthers are really out there. That'll tell you how many are really out there, man. All right, people. So I said I wouldn't. I can't believe Robert haven't what? You can't believe I haven't what, Richard? Talk to me, brother. People, I have to admit, man, I'm fucking tired, man. I gave a lot of you guys access, man, to them damn files I have. And I haven't been seeing too many people, man, looking at a lot of documents. I'm a little disappointed. I haven't seen too many people reading a lot of documents, man. You guys should be downloading that shit like crazy. Because if something happened to me and I get kidnapped or some shit, or somebody try to kill me, somebody got to carry on. Rose Patton says, fuck Robert. I'm going back in the chat. Yeah, I love it, man. You know, here's the thing. I live by the Machiavellian philosophy. It's better to be hated than loved. All right, Jeff goes by that too. Jeff, what, most hated man in the flat earth? I'm trying to dethrone his ass. But I think people hate me for the fucking wrong reason. I really do. I think they don't like my ass for the wrong reason. Could be the sound of my voice or whatever. He says, I enjoyed it until the fallacies got too repetitive. I hear you, political hillbilly. Political hillbilly, I tell you what, you said something really fucking interesting today that, I mean, that it was profound. It was simple, but it was profound. And the profoundness I found in what you said, political hillbilly, was when you were arguing with that guy and you said, you know what, man, the earth is stationary. The atmosphere is not attached. The atmospheres that are moving are not attached to the earth, the stationary earth. And man, that did it right there. You could have ended the conversation right then and there. People hate my crickets, man. I tell you what, I'm gonna start inviting you people down here and you'll see what I'm talking about. Ain't nothing you can do about it. If I close the windows, it'll be a fucking hot box. Chocolate crickets are good. Oh, you nasty, man. You fucking bugs. All right, peeps. I'm gonna shut this down. Oh yeah. Tracy's in here, Jeff's wife. Tracy, I love you, just like a sister. I am glad you are here. I love you like a sister. But if your husband don't give me a call and officially apologize to me just for being the damn pain in my ass that he is, I ain't gonna talk to him ever again. He needs to learn how to humble himself. Tell him Mr. BASSANO would appreciate his presence. But you know how Jeff is. He's sitting up on his fucking flat earth throne and shit. All right, people. There's a lot of documentation out there waiting to be read. I'm going to keep doing some reading, but the next video I'm going to put out will be on Monday. I said, if you're not working, put it on your calendar. I'm going to make that call around 2 o'clock Central Standard Time, and that'll be 3 o'clock Eastern Standard Time. And I'm going to call to speak to Freeman Dyson, retired Professor Freeman Dyson. And I want to talk to him about his paper on the flat earth model. If he says what we want him to say on his own, just by asking questions, all of you are more than welcome to mirror the fuck out of that video. Mirror the fuck out of it. Mirror it till you crash YouTube. And you know me, when I do these interviews, I ain't using foul language, I ain't cursing at people. I definitely ain't gonna be cursing at Freeman Dyson. Unless he says some crazy shit like, are you mad? Are you mad? It was just a paper. I don't believe the earth is flat. And then I'm gonna curse his fucking old ass out. But I don't think he's gonna do that. I don't think he's gonna do that. So 2 o'clock Central Standard Time on Monday, 3 o'clock Eastern Standard Time. And what would that be? That'd be 1 o'clock Pacific Standard Time, I think. We're gonna call Mr. Dyson. I'm gonna do a little test call with him tomorrow, just to see if he'd be available on Monday. So I might put up like a short little 10, 20-second intro tomorrow to let you know that, yeah, the call's gonna happen. That somebody says, make it 2:45 Central, please. Bill G. If I make it 2:45 Central Standard Time, Bill G, what does everybody else get out of that for doing it at 2:45? I want to see what he's going to say. Come on, Bill G. Why 2:45? Richard Clark says Dyson sphere equals cell Earth equal dick Earth. There are a couple of those for Justin. Which one? Nothing at all. Okay. It'll be somewhere between 2 and 3 o'clock, people. I'll put it out there for you. Don't worry. But I'll put up I'll put up a little 15, 20 seconds tomorrow because I'm going to do a test call to see if that's really his number. If it is, I'm going to say, yeah, Mr. Dyson, would you be open to having, you know, a 1-hour interview with me, a recorded interview? I'd like to ask you some questions about a paper you wrote. And if he says yes, you know I'm going to pull the graduate student thing on him. And yo, it's on, baby. It's on. All right? You know who I'd love to have in this chat, too, with me on the panel, would be Tracy Stewart, because she's a graduate student as well. How about it, Tracy? You going to join me, little sis? Or Richard Clark? Or Event Skeptic? Anybody? Bueller? 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 Oh, everybody's silent now. Ain't no chat moving. All right, people. Have a good night. And I'll put up, not tonight. I know not tonight, Tracy. I'm talking about Monday. If we can get Freeman Dyson, would you want to be on the panel on Monday? Those aren't crickets. Yes, they are crickets. All right, people, it's been fun. I got to get some rest. You guys take care. All right? I got love for all of you. Be good to each other. Remember, it's not what you know, it's what you can prove. This is the real flat earth math and model. Share it with everybody. Take care. Ciao.